Hello everyone, this is Paramveer Singh and you are watching my YouTube channel GatePro. Today we are going to start a new chapter, that is state space analysis. Previously we have done the analysis of a system using various type of techniques such as Routh's criteria, root-locus method, frequency response analysis, and in that we use the technique of polar plot, Nyquist plot and Bode plot. But all of these techniques have been used using the transfer function of a system, and which is calculated only for a linear time invariant system, and while doing that we ignore all the initial conditions, that is initial conditions are taken to be 0, plus it is only calculated for a single input single output system. But if we have a system like this that has multiple inputs and multiple outputs, to analyze this system we cannot use those techniques, and how do we do that we will learn in this chapter. To analyze a multiple input multiple output system, we need to create a two set of equations combinedly, that is known as the state model of a system. The first equation is the state equation, which is x dot is equal to ax plus bu. The second is output equation, which is y is equal to cx plus du. Combinedly these two equations is known as the state model of the system. To understand these equations, we redraw the multiple input multiple output system over here. Let's say we have m number of inputs applied to this system, which is denoted by u1, u2 up to so on um. Combinedly this input set is known as u, and due to these inputs we have multiple outputs like this y1, y2 up to so on yp. The set of these outputs, let's say, is y. We have another set of variables over here, x1, x2 up to so on xn. Combinedly this set is known as x. So these variables that have been applied to over here are known as the state variables. If we have the knowledge of these state variables at time t is equal to t naught, and the knowledge of these input variables for time t greater than equal to t naught, we can find the value of all these output variables for time t greater than t naught. Over here this x represents the set of all the state variables, and this x dot is the first derivative of these state variables. This x is called the state vector. This u over here represents the set of input variables and is known as input vector. This y over here represents the set of all the output variables and is known as output vector. In here these a, b, c and d are in the form of matrices, and the a is known as system matrix, b represents the input matrix, c represents the output matrix, and d represents transmission matrix. So if we convert a system into a set of equations, the first one is of this form: and the second one is of this form. We can find the state model of that system. And how do we do that? We will learn by using an example.